Welcome to the section of NumPy and Pandas. We will be first starting with NumPy package. This is the most commonly used Python library for your data science work. Now, as the name itself is NumPy, we can break it into two parts. So this num we can denote it as numerical. Okay, so this you can denote it as, let's say, numerical. And the second part, py, you can represent it as Python. Now, this is also sometimes also called as array oriented computing, because in NumPy, just like your list in Python, you will be able to work on your array kind of data structure. This package is mainly written for your scientific computing and data analysis. We will be walking over multiple examples to understand this, that what does this mean. What is the basic NumPy object? It is going to be your n-dimensional array. Sometimes we also denote this by ND array. Now, one important property about this is that this need to be homogeneous array. Homogeneous. Now, as I said, that this NumPy is gonna mostly have like list kind of data structure. You can have lists, tuples, anything. But so basically what we keep in list, right? We keep the values like this. If you remember from your Python section, we keep the values like this, right? So in a similar manner, we will be creating our NumPy array. But all the values which need to be present inside it, they all need to be of same data type. So let's say your 1 is of type integer, then 2 should be of also type integer, 3 should also be of type integer. And usually in NumPy array, we keep either float or integer data type. This is something we generally do while working with our NumPy. Now, very interesting question. Why NumPy? Now, I'm just saying that NumPy is kind of like list. Then why we even need like a NumPy n-dimensional array? Because when we already have something like list available in Python, why we have taken so much of pain in creating a separate package for it? Why not we do all the data science analysis by just your Python list? Number one reason, and very strong reason, it is very fast. It is very, very fast. And second is it's computing. It's very easy and very convenient to work on your NumPy package. The reason it is fast is, the first reason is definitely because it's the implementation is completely into your C programming. So at the back end, everything runs with respect to your C programming. So behind the scene, this is going to run. Okay, so it avoid all the general cost of your loop in Python or your indirections and per element dynamic type checking. So all this is kind of reflected. What I mean by this statement, when you're working with your Python list, what you generally do is you will be having a list, and let's say if you're performing a sum operation on that list, what you are actually doing is you are looping over that list one by one sequentially, and then you are adding those elements, right? So you are doing something like this. Let's say you have a list having like 1 comma 2 comma 3 comma 4 comma 5. So what you are doing is you are sequentially going over them one by one, like you are going like 1 plus 2, which is 3. Then let's say you did 3 plus 3, 6. So you are looping over them one by one and adding them up, right? So it's happening in a sequence, continuously happening in a sequence. But what NumPy do, NumPy take the advantage of parallelism. So NumPy because all the some elements are going to be independent of each other. So rather than you doing the sequential operation, it will try to use the parallelism. So it will sum two elements at a time parallelly. So here like you have 1 comma 2 comma 3 comma 4. So maybe it can do, let's say, sum of these two elements and these two elements parallelly, and then basically what's output is coming, you can again combine them. So that way it is going to leverage the parallelism, thus making the things faster. Still not convinced? I will show you an example, in fact more than one example, to show you, to prove it to you that NumPy works far better in comparison to your normal Python list. And NumPy is also going to take less storage. That's awesome. You can save a lot of space. The way it is written, it is very compact in comparison to your list. Finding it interesting? We are going to now explore our NumPy package practically. And we will see that why it's fast, why it is convenient, all these things which I have just mentioned. I'm going to now show you all these things practically so that you can understand that well.